Hello friends, let us start with this chapter 4, describing motion around us. Look at this picture. You can see something is written on the back of the truck. Keep a safe distance. Now, everything in nature is in motion. First of all, tell me what is motion. So, suppose you put on the fan. The fan is moving. Earth is moving. Sun is moving. Okay, my hand is moving. Everything is in motion. Molecules are in motion. So other examples are given here: butterflies, slithering snakes, hopping hares, galloping horses, tendrils of climbers twining around the support, closing of fly trap. So all these are the examples of motion. Sunbeam, you can see the smoke particles moving in air, rising and falling of ocean tides. So all these things are wonderful. So first of all, try to understand what is in motion. Motion is the change in state of an object. Okay. So if an object changes its position with respect to time, we say that it is in motion. So we have read in the first chapter, to explore the complex phenomena, first of all we have to simplify it into models. So such type of motion can be linear, circular, oscillatory, that we have learnt in earlier grades. Actually motion is very complex. We simplify it in these types. So we are going to learn about linear motion and uniform circular motion in this chapter. Okay, we are going to simplify it. We are not going to study all types of motions. These two primarily we are going to study. So we are going to talk about distance, time, speed. You have heard about it, you have learnt about it. Then we are going to talk about displacement, average velocity, average acceleration, and so on. So first of all, whenever an object is moving in a straight line, we say that it is in linear motion. Now you might have seen some examples. You can see that a car is moving in a straight line. The people who are in swimming tank, they are moving in a straight line. Okay, so train moves in a straight line on the tracks. You can see an example here. So we need to discuss about the motion of object. You first need to describe the position at various instants of time. Okay, this is one instant. My finger is here, then I move it here. Earlier it was here, then it is here. That means I have changed the position with respect to time. So first of all, we have to have a reference point, a fixed point. Okay, you are inside a car, you are looking outside. Okay, with respect to you, the things are going behind. Actually the car is going ahead, but you feel as if the things are going behind. So it depends on you. You are the observer. So like that we have to fix a point, reference point, and then compare other things, other substances with respect to that fixed point. That point is called reference point. So with reference to the sun, earth is moving around the sun. With reference to earth, moon is going around the earth. So distance and direction of the object with respect to the reference point at any given instant of time describe the position of object. So we need to specify what is the reference point. If the position of object changes with respect to time, then we say that it is in motion. Otherwise we say that it is at rest. Okay, I am sitting in the car beside you. The car is moving. I will feel as if we are sitting beside each other. We are not moving, because with respect to me, you are not moving. You are inside the car. Together in the car we are moving. Okay, so that's the thing. Position, where are you with respect to a reference point, at rest or in motion, depends on that fixed reference point. It can be different. People who are outside the car will feel that we are going ahead. If they stand in one place, they'll see our car is going ahead, and inside the car will look at the people outside, will feel as if the people are going behind. So if the position of object with respect to reference point changes with time, we say that it is in motion, otherwise it is at rest. Here the example of an athlete running on a straight track. You can see a reference point and position point of the athlete with respect to the instant of time. So starting from 0 meter, then 20 meter, 40 meter, that is point B, then 100 meter is point A. So if you take origin as 0, that is O, then you can tell where the person is, where the athlete is with respect to the reference point. So you have to fix a point, that is reference point. Now to describe the position of an object, we need to specify the direction. In which direction? Positive, negative, left, right, you have to tell the direction. So direction represented by plus and minus, forward, backward. Positions right and left are generally taken positive and left is negative. So right is positive, left is negative. Generally, we have generalized it. We have decided it. Scientists, the scientific community. Now distance traveled and displacement. So distance and displacement, two different concepts are there. Try to understand. Suppose an athlete starts running from point O, time is 0, reaches at point B after 4 seconds, and then reaches point A 10 seconds, runs backward reaching point B. How much total distance he has covered? So you start from O, okay, you go to A, then you come back to B. The time is given to us. So you have to find total distance. So how will you find the total distance? You will count from O till A and add from A to B in reverse direction. So add all of that. That will give you the total distance. If you go from Pune to Mumbai and Mumbai back to Pune, the total distance will be distance between Pune and Mumbai into 2, because you have gone and came back. Now displacement, on the other hand, it considers only the starting point and the ending point. Now in this case, starting point is O and ending point is B. So we are going to just find the distance between O and B. That will be called as displacement. Minimum distance from point O to point B will be the displacement. In case of Pune to Mumbai and Mumbai to Pune, if I start from Pune and come back to Pune, displacement is 0, because starting point and ending point is the same. Remember, distance and displacement are different things. So displacement is the net change in the position of an object between two given instants of time. Where is the point now? Where it will be after some time? Starting and ending points. So we have a numerical value also, which is called as magnitude, and of course direction is important. Magnitude of displacement is the distance between the object's position at two instants. The direction of the displacement specifies the position at the first instant toward position at the second instant. So describe the total distance traveled. Only numerical value is required, not the direction of motion. Okay, SI unit for both of them is meter. For distance, only value. For displacement, value as well as direction, both are important. For distance and displacement, both have the same unit, meters. That is the system international unit. Everybody uses this all over the world. Now let us analyze. Here they have given a table in which positions are given O, A, B, C, D, O again. So you can just find out the distance between them and you come back to the same place. When you come back to the same place, displacement is 0, remember. You start from O, you come back to O, displacement is 0. Now analyze it, and they have given some points, you can just observe them. Here they have given another example of a ball rolling from different points. They have asked some questions, you can understand very easily. Now average speed and average velocity. Now motion changes, change in position of object with respect to time, terms of total distance traveled and its displacement. So average speed and average velocity. Let's try to understand. Average speed of an object is the total distance traveled divided by total time. Okay, time interval which is distance covered. So total distance upon total time. Now, since distance traveled has no direction, which is calculated from the distance traveled has also no direction but only numerical value. If an object moving in a straight line travels equal distance in equal intervals of time, we say that it is in uniform motion in a straight line. Remember, equal distance in equal intervals of time. This is very important. Uniform motion in a straight line. So in case the object moves at a constant speed, on the other hand, if the object travels unequal distance in equal intervals of time, we say that it is not in uniform motion, it is non-uniform motion. So if the distance traveled in successive intervals of time increases, its speed is increasing. Okay, you go faster, your speed increases, you will cover more distance in the same amount of time. Try to understand this. Now, here they have given the contribution of Indian scientists, the old people who were learned and wise. They have contributed. Aryabhatta was there, so he has contributed a lot. It is written here. Mathematical texts were written 14th century, which was very famous at that time. Consider two postmen. They started walking towards other from a distance 210 yojan. Yojan is a unit of distance in ancient India. One travels 9 yojan per day, other covers 5 yojan per day. So can you determine how many days they'll meet each other? So here they are given the answer 9 plus 5, 14. So to meet each other they need to cover 210 yojan together. So it will take 15 days. So what they did, they added number of yojans in one day and they divided 210 by it. You get 15. So if both postmen meet each other after 15 days, that is the answer. The speed tells us how fast you are going. If you are going very fast, so the speed will be high. If you are going slow, the speed will be less. In many situations where along the speed you need to know the direction of motion to get a complete picture, particularly in case of complicated real world motions. So average velocity is equal to change in position upon time interval, displacement upon time. This is the formula you have to remember. Now to express average velocity, you need to specify magnitude and the direction also. So the SI unit of average velocity and average speed is same, meter per second. It can be kilometer per hour, that is another unit, but you have the SI unit, that is meter per second. The ratio of change of one quantity with the corresponding change in time is called as rate of change. How rapidly it is changing, that is a rate of change. Sarang takes 50 seconds to swim from one end to other and back. Find the average speed. So average speed is total distance upon total time, that is 50 upon 50, that is 1 meter per second. And average velocity is 0 because its starting and ending point is same. So no need to calculate anything. Displacement upon time is 0. Another examples are given. Pause and ponder. You can read it and solve it. Average velocity of an object over a large interval may differ from its velocity at a particular instant. So throughout this chapter we'll use velocity to mean velocity of an object at a particular instant. Now what is acceleration? So acceleration is change in velocity upon time intervals. Remember this formula. Acceleration is change in velocity upon time. Now what is average acceleration? Change in velocity upon time interval. Final minus initial upon time interval. That is average acceleration. So you increase your speed, that is acceleration. You decrease your speed, that is also acceleration. Positive and negative acceleration. Now you can see the velocity and acceleration, they are in same direction. And velocity and acceleration can be negative, they can be in opposite direction. For example, car is slowing down. So car is moving in forward direction, it has a velocity, but when you apply brakes, that is negative acceleration, that will reduce the speed of the car. Now average acceleration can result in from change in magnitude of velocity or change in direction or both. So if you change the direction, velocity what will happen? Average acceleration is going to change. So let's calculate. So they have given the examples here. You can solve these examples, read this, very easy. So a bus is moving along a straight highway with velocity 36 km per hour. The driver presses accelerator for time interval 10 seconds and then the speed increases to 54 km per hour. For some time the bus moves at constant velocity. Then the driver notices an obstacle and he presses brake. Now the bus comes to a stop in a time interval 5 seconds. Now what you have to do is you have to find the average acceleration when the accelerator was pressed and when brakes were applied. So first of all, you will convert kilometer per hour into meter per second. 1 kilometer is 1000 meter and 1 hour is 3600 second. 16 to 16. So you divide it, you get the average acceleration. Then magnitude of the bus increasing, the acceleration again acting on it. So you calculate it, and when brakes are applied, you calculate that also with the same formula, and you get -3 meter per second square. Average acceleration during different time intervals can either be constant or changing. From an object moving in a straight line in the same direction, if the magnitude of the velocity increases or decreases in equal amount, then we say that it is constant, that is acceleration is constant. Another example is given, average acceleration is there. You can just observe it, you have to read it, write it, then only you will understand. Now let's go to the graphical representation of motion. So it's very useful to draw graphs. It gives a picture. Mathematics really helps science in this way. So you can draw different types of graph. So to represent the position, velocity, acceleration, you get many things from it. So look at this table. We have position 0, 1 second, 2 seconds and all, and 20 meters, 40 meters, 60 meters. So you can draw a graph related to this. You have shown us the graph. Take a sheet of paper and pre-divide it into smaller squares. So it's there, smaller squares will help you to draw the graph. And now you draw a horizontal line and vertical line and show time and position. So you can have the graph like this, time and position graph, represent the values and join those, and you will get a line like this. Okay, so this table is there. Observe the table. I know you know how to draw the graph. 0 second, 1 second, 2 second, and observe this. See time 0, 1, 2, 3. Time is there. Then position is there in meters. You join them, you get a straight line. Very simple. Observe this graph now. What is happening? So this table shows us the time position graph. 0 second, 2 second, 4 seconds. So the time is increasing by 2 seconds. But the position is not constant. Earlier it was slow, then suddenly the position changed a lot. So you'd see the graph. It's a straight, not a straight line. It is a curve that is going up. This kind of graph can be there. So what do you understand by these graph? So position time graph. A position time graph represents the motion of an object and the change in position with time. So you look at these two graphs, observe them carefully. You can see the difference. Constant velocity and constant changing velocity. So constant velocity is a straight line and changing velocity is a curve. Okay, whatever the data is given, you plot it, you will get this kind of structure. So as we see, it's a straight line. Position time graph indicates the object moving in constant velocity. On the other hand, curved position times, they do not show it. So you can calculate. Example is given. Please see this. Now, what does the graph show? Look at this graph. Position time graph. It's a straight line. At 40, it is fixed. So what does it mean? So with time, the position is not changing. Okay, this is a position time graph. So it's a straight line parallel to the time axis. So it represents a stationary object. The object is not moving at all. That's why we get a straight line for position time graph. Now position time graph of two objects A and B are given. When object is in magnitude of average velocity is higher. So you have to observe A, B, and they have given us the graphs. By making lines parallel to the axis, it is found that displacement of object B is more than object A for the same time interval. So first of all, they have shown the graph, and then they have drawn lines on the graph, and they've told us, okay, what do you understand from the graph. Looking at the graph, you should be able to understand. So by making lines, we understand that displacement of B is more than that of A. Look at this displacement of B, red color, that is more. Time is increasing equally, but the position of B, it has increased a lot. That means it is in motion and faster, changing its position with respect to time. Okay, we'll continue in the next period.